So we'll start with amines and amides. These are other functional groups that you would see commonly in a lot of organic compounds, and these would be very prevalent in our the biomolecules that are found in our body. For instance, the DNA, you would see there's a lot of nitrogen present in there. Okay, so we'll talk about those later on, but first let's start with what exactly is amine. Amine essentially is a derivative of ammonia. So ammonia is NH3. Where do you see it? Ammonia, you might have heard of it as a cleaning agent, right? In bunch of like those what is that? Bleach and stuff. Those have certain amount of ammonia in them, right? So it has a very pungent odor, ammonia. And if you try to take derivatives out of it, usually it is based, if we try to write its kind of Lewis structure, it would look something like this, where we have nitrogen bonded to 3 hydrogen and nitrogen has lone pairs. Okay, so this is how ammonia looks like. Usually you would see, if you have covered acids and bases, you would see that ammonia can act as a base. So what it does is, essentially you would have ammonia in water. It acts as a base by accepting the proton from water. So here water donates its proton to ammonia, and ammonia changes to NH4 plus. Okay, so this is also a derivative of ammonia. Other derivatives of ammonia would be what you see in organic chemistry would be, you see that it has 3 hydrogens. If we talk about neutral ammonia, that is NH3. This ion is called as ammonium ion, NH4 plus. Okay, so this, if I try to now replace each of these hydrogens, it basically has single bond with 3 hydrogen. If you replace 1 hydrogen and put an R right here, R meaning a carbon chain, you could replace this hydrogen, put an R right here, you could replace this hydrogen, put an R right here. So these are basically how you would have different amine derivatives in organic chemistry. Okay, so you would replace these hydrogens with a hydrocarbon chain. Okay,
that would be considered amine.
They are all considered amine derivatives. They are all derivatives of coming from ammonia. You could also have an ammonium derivative, for instance like this, where you could replace all 4 hydrogens with another alkyl group or any other carbon chain. That would also make it an amine derivative. This would be essentially ammonium, and it would have a charge, it would be ion, whereas if a nitrogen has 3 bonds and 1 lone pair, it is regarded as a neutral compound. Okay. So these are derivatives of ammonia in which 1 or more hydrogen atoms are replaced with alkyl or aromatic groups. They contain nitrogen attached to 1 or more alkyl or aromatic groups. For instance, you can see right here, this is 1 nitrogen, and here all 3 hydrogens have been replaced with alkyl groups. This is another example where only 1 hydrogen is left, but 2 hydrogens have been replaced with another alkyl group. So you could replace 1, you could replace 2, you could replace all 3. Okay. This is another derivative, it's an aromatic compound, right? So this compound is called, when you have benzene, this was covered previously, when there is a benzene ring and it has amine attached to it, this is called as aniline. Okay, so this is a common name, but it is also considered by IUPAC system. So you could use aniline for the name of an amine attached to an amine group attached to a benzene ring. Okay, this is called aniline, and then we'll see how we can name the rest of the amines in a second. Okay, so how do you name them? In case of IUPAC naming of amine, the E in the corresponding alkane is replaced with amine. So if the amine is looking like this is when your amine has 2 hydrogens and we have only replaced one of the R groups, one of the hydrogen with an R group. In that case, it would simply be alkane, but instead of E, you would use amine. Okay, this is only true when this nitrogen has 2 hydrogen atoms. Okay, there's only one alkyl group. So for instance, what would this be called? The first thing you recognize that this has an amine group. The second thing you see here is it has 1 carbon. So 1 carbon means usually it would be called methane, but instead of having this E at the end, we would put methane amine.
It's only that as H2.
It has to have an H2. So nitrogen only has 1 R group attached to it. Okay, only then this naming would work. Okay. For instance, right here, what do we have? This is again an amine group. Where is this? Okay, we'll talk about that in a bit. So when you recognize this, you would first see that, okay, this is an amine derivative. So the functional group here is amine. Now, how do you name it? You again do the same thing. You are naming your alkane. So you find the longest chain of carbons. The longest chain of carbon is right here, right? So what is this? What would be the name of this? It's this. This is the compound. What would be the name of this? This is 1 and 2 carbon. So 2 means it's ethane, and it would be ethane amine. And in this case, where is the amine located? It is attached to carbon number 1. So we don't have to tell where the location of the amine is. But if it is not on carbon number 1, then you would have to tell where the location is, right? Also, there's, in case of amines, when the carbon number is more than 2, when the carbon number is more than 2, usually you do tell where the amine is located. Even if it is carbon number 1, you would mention exactly where the amine is. So for instance, if we are naming this compound, first thing we recognize is, okay, the functional group here is amine. The second thing we see is we need to find our longest carbon chain, which is right here. You would start numbering from the right side. Why? Because our functional group has to have the smallest number. So again, 1, 2, 3. 3 carbon is propane, and instead of E at the end, we would have propane amine. So propanamine. Okay. Now, since this is more than 2 carbons, you do have to mention exact location of the amine. So where is the amine located in this case? It's bonded to carbon number 1. So this is going to be 1 propanamine. Okay. For instance, if you see this, how would we name this? This is also 1, 2, 3 carbons. You could start numbering your carbons from left to right or from right to left. It doesn't matter. It's going to give the amine the same number. So it should be okay wherever you start numbering. So in this case, it's again 3 carbons. So it would be propanamine. But where is the amine located? It's on carbon 2. So it is 2 propanamine. Okay. For instance, this compound right here, how would we name this? Again, we recognize there's an amine. So we find the alkane chain. The longest chain is right here. Where do I start numbering? Should I start from the left or from the right? From the left, because this would give our amine the smallest number possible. So 1, 2, 3, 4. 4 is bute. So it would be butanamine. And where is the amine located? On carbon number 2. So it is 2 butanamine. Okay. If we are naming this, so again, the functional group you see is amine. So naming is very similar. It continues from alkane. Whatever you name the alkane, it is basically a derivative of alkane. So this is my functional group. So I know based on this functional group, my name has to end with amine. Now let's find our longest chain. I could do 1, 2, 3, 4 straight, or I could go up. That would also make it 4. So either way is okay. So this now is my substituent, which is methyl. Where is it located? Carbon number 3. So it is 3-methyl. Where is the amine? Carbon number 1. And how many carbon total? 4. So it would be butanamine. And where is the amine? Amine is on carbon 1. So 1 butanamine, and then the substituent, which is 3-methyl dash 3-methyl dash 1 butanamine. Okay. Any questions? Okay. Now what happens if there are more than two hydrogens or more than all the three hydrogens replaced? In that case, naming is a little different. Okay, if there is an alkyl group attached to the nitrogen, so this first thing what you do here is when you look at this compound, you see that this is an amine derivative. There is a nitrogen, so this is an amine derivative. Okay. Next thing you notice that there is two hydrogens that have been replaced. There are two alkyl groups attached to this nitrogen. So how would we name this? You would again find the longest chain. Okay. So this right here is my longest chain. There are two chains here. This is my longest chain. So I'm going to name it just like how I name my normal alkane. And forget about this for now. Okay. So this is carbon 1, carbon 2. 2 carbon is ethane amine. Perfect. Ethane amine. And where is the nitrogen amine on carbon 1? This is less than 3 carbons. So we don't have to tell exactly where it is located. And now what do we have? We have one more alkyl group attached to the N. Okay, so we have this now is our substituent on the amine. Okay, so we have a methyl attached to ethanamine. So how would we name this? We would tell that we have a methyl group, and where is it? It is attached to N. So instead of putting a number of carbon, because it's not attached to carbon, we would tell exactly where it is located. So this would be N-methyl ethanamine. Okay. What happens if I also replace this hydrogen with another methyl? Then it would have two methyl groups. So how do you name when there are two substituents? We usually put N-N dimethyl ethanamine. Okay. Does this make sense? So you simply, instead of putting the numbers, now you're telling me exactly, because there is only one amine on this compound, right? So you're telling me that the methyl group is located on nitrogen. So I don't need a carbon number because it's not attached to carbon, it's attached to nitrogen. Okay. So for instance, if we are naming this compound, when you look at this compound, the first thing you recognize is I see a nitrogen. So the functional group here is amine. And then we see that there is longest chain and these alkyl groups are attached to nitrogen. So I need to first find my longest chain, which is right here. 3 carbons. So what would be the name of this? Propanamine. Perfect. Propanamine. And where is this nitrogen or amine attached to which carbon? Since it is more than 3 carbon, we have to tell exactly where it is. 1, 2, 3. So it would be 1 propanamine. Now I need to name my substituents. So I have a methyl. Where is it? On nitrogen. Another methyl. Where is it? On nitrogen as well. So this would be N, N dash dimethyl dash 1 propane amine. Okay, so you simply use whatever. If nitrogen has more alkyl groups, you use them as a alkyl or a substituent group. Okay, for instance, if we are naming this compound, I see this is an amine. There is 1 carbon, there is a 2 carbon chain, and then there is a 1, 2, 3, 4, 5 carbon chain. So that has to be my longest chain. And again, I would number from the left side because my nitrogen would get the smallest number possible. So 5 carbon would be pentanamine. Where is the nitrogen located? I first have to name the amine, okay, complete the parent chain name. So pentanamine, where is the amine? On 2. So it is 2-pentanamine. Now we go to substituent. We have N, this is methyl. It's on N, and this is ethyl. Perfect. And this is also on N. So it would be N, ethyl, methyl, 2-pentanamine. Or actually no, you can't do N, because that is when you do dimethyl, trimethyl, if it's repeating. So you put them individually. N-ethyl, N-methyl, 2-pentanamine. And how do we decide who comes first? Do I put methyl first or ethyl? Alphabetical order. Perfect. Then we put these in alphabetical order. So it would be N-ethyl, N-methyl, 2-pentanamine. Okay. Okay, how would we name this? Perfect. What did he say? How many carbon is this? 4. Butanamine, perfect. And so perfect, it's 1 butanamine. That is methyl, and where is it located? On N. So our substituent is N-methyl, so it would be N-methyl-1 butanamine. Easy. Okay, perfect. Okay, if there is benzene, I already mentioned that if there is one of the benzenes there, you would basically call this as, this would be regarded as aniline. Okay, now in this case, if I take this, oops, should have done this in previous slide, but if I take this and let's say I do NH and there is a CH3 here, how would we name this? So we know that this right here, this is called the aniline. This whole thing is called aniline when there is amine. Okay. Yes, perfect. So there, this is my substituent, so it would be N-methyl aniline. Perfect. Okay, so benzene doesn't make really much difference. Only thing, if you see benzene with the amine, just remember now this would be your carbon number 1. If I add something, if I add another substituent to, let's say, this side, this is my amine, and let's say I added a methyl right here. I added one substituent right here. How would we name this? This is still aniline, right? And then this is regarded as a substituent. And where is the substituent? We have to number the carbons now. So how do we start numbering? Numbering will always start from here. 1. You could go left or you could go right. Which way should we go? Right, because it gets the smallest number. Perfect. 1, 2, 3. So this would be 3-methyl aniline. Okay. So nothing changes. Only thing you have to remember is whenever there is a benzene with amine, remember that is called that parent chain is regarded as the aniline. Okay. All right. Now we'll talk about different classifications of amine. Okay. So amines can be classified into 3 different types of amine. One is a primary amine, secondary amine, and tertiary amine. What are these? Primary amine is an amine where amine is attached to one carbon group, one alkyl group. Okay. When it is attached to one carbon group, it is primary. When it is attached to 2 carbon groups, it is secondary. When it is attached to 3 carbon groups, it is tertiary. So for instance, if you replace one of the hydrogens in amine with a carbon group, it is primary. Primary is usually written as 1 with this prime, or you can say it as a degree sign. Secondary would be, for instance, right here, nitrogen bonded to 2 carbon. It doesn't matter if there are more carbons after this, it doesn't matter. What matters is how many carbon is nitrogen directly bonded to. Okay, so it is bonded to 2 carbons directly, so this is secondary. Here nitrogen is bonded to 3 carbons directly, so this is tertiary. Okay, why is this important? We'll see. So here you can see another example. This is ammonia. This is primary amine because it's one methyl group, so methylamine. This is dimethylamine, right? This is trimethylamine, so this is tertiary. Okay. Okay, these are some common names. I will probably not ask you for common names, but in case if you ever see this in question, it's based on the same idea. What they do here is, in case of common names, the name is usually called as alkyl amine. Okay, so for now what we were doing is methane amine. We named the alkane and then we added amine at the end, right? In this case, instead of having the name of the alkane, you have the name of the alkyl group. So everything that is attached to the amine is regarded as an alkyl group when you're naming it common. So for instance, this has Nitrogen has which group attached to it? 2 carbon. 2 carbon alkyl is called ethyl. So it is ethylamine. Here what do we have? I have nitrogen which is attached to 2 methyl groups. So it is called dimethylamine. Then here we have, this is methyl. This is methyl. This is ethyl. So the name would be, basically this methyl and methyl will be written as dimethyl and ethylamine. Now the question is, which comes first? Alphabetical order. These prefixes that we see, di, tri, tetra, they don't count towards alphabetical order. What counts towards alphabetical order is the actual name of the substituent, which is M and E. So ethyl comes first, so the name would be ethyl dimethylamine. Okay, you could replace here with one more ethyl group instead of methyl, then it would be diethylmethylamine. Okay, so as long as, of course, you could make branches in the substituents, but I will not ask you those questions. That is out of your syllabus. The way you would get the question would be very simple, like this. Like there would be an ethyl, propyl, or butyl group. Okay, some normal group which is not branched. Okay, but again, I will not ask you to name something with the common name. I would probably be asking you IUPAC, but you should still know how. If you see these names, these are still talking about the amines. Okay, these are just common names for amines. Okay, so for instance, if we were to give the common name for each of these amines and classify as them primary, secondary, or tertiary, how would we name the A? Perfect. This has a propyl group, so this would be propylamine. And is it primary, secondary, or tertiary? Primary. It has only one bond with a carbon atom. Perfect. How about this? I think we did this already. Yes. Perfect. This substituent is ethyl. This substituent is methyl. This substituent is methyl. So we have dimethyl, but the alphabetical order would tell us that we should start with ethyl dimethylamine. And is this primary, secondary, or tertiary? Tertiary. Perfect. The nitrogen here is bonded to 3 carbons, so it is a tertiary amine. Now next thing, if we were to name it IUPAC, what would be the name? We find our longest chain, right, which is ethyl. So ethane, not ethylamine. Ethylamine is the common name. So ethanamine, yes, ethanamine. Okay, and then we have, where is it located? This is less than 3 carbons, so we don't have to tell exactly where it is, but we do have to tell the substituent. So I have a methyl. Where is it located? N. This is also on N. Perfect. So this would be N, comma N, dimethyl ethanamine. Yes, so that is how you would name it. IUPAC, this would be its common name. Okay. Oh, now we come to aromatic amines. So you can see right here, this is called aniline. Okay, so if we were to name this compound, how would we name it? This is the amine group. So I know what is my parent chain called. It is called aniline. And I have a substituent which is bromo. Where is it located? Carbon number 1, 2, 3, 4. So carbon number 4 means 4 bromo aniline. Okay. Now in this case, if I were to name this compound, how would we name this? First thing you recognize, this is a benzene with amine. So the parent chain, which would be right here, this would be our parent chain, which we call as aniline, right? Now we have this substituent, which is methyl, 1 carbon. Where is it located? On nitrogen, so it is N-methyl. So name would be N-methyl aniline. Okay, so naming is exactly same, only difference is you have to remember this particular structure, that whenever there is benzene ring with amine, it is aniline. Okay, where do you see aniline? Aniline is basically found, it is used to make many dyes. So this can provide color to basically a lot of fibers. It is found in bunch of dyes, different color dyes, where for instance all the wool, cotton, silk fibers, jeans, most of the clothes, they are dyed with this color, aniline, and its derivatives. Okay. Okay, write the common name for each amine compound. So if we were to name common name for this, perfect, this group is ethyl. Common name means we need this as the alkyl chain, right? So this is ethyl, this is ethyl, this is methyl. So it would be, which comes first? Alphabetical order. So ethyl comes first, right? And it diethyl. It doesn't matter. Remember, this di doesn't matter towards alphabetical order. So it is diethyl methyl amine. Okay. How would we name this in the IUPAC system? Find one long chain, right? So this would be, let's say, my long chain. I regard this as my long chain. So this would be 1, 2. So the name would be perfect ethanamine. Now I need to name my substituent, which is ethyl methyl. Where is it? On N, on N. So which one comes first? Ethyl comes first. So this would be N dash ethyl dash N dash methyl. So regard this N as a number. Just how we were writing a dash between number and alphabet, we are going to do the exact same thing. This N is basically regarded as a number. It is telling us exactly where our substituent is. Okay. Okay, so now how would we name this? This is again perfect. This is aniline. What is this? Ethyl group. Where is it located? On N. Perfect. So the name would be N-ethyl aniline. Perfect. Okay. All right. Now we talk about line angle formula for amines. I mean, it's same. You can clearly see there's no difference here. There's nothing new here. When you have an amine, you simply draw this, and you do have to show the amine, all the amine groups. Okay. In this case also it's the same rule. In line formula you basically just don't show the carbon and hydrogens, but everything else you do show. So if there is any hydrogen attached to nitrogen, you do have to show those hydrogens. We don't show the hydrogens that are attached to carbons, but we do show every other hydrogen. If it is bonded to oxygen, we show it. If it is bonded to nitrogen, we show it. If it is bonded to sulfur, we show it. Okay, so the same rule applies here as well. If you're drawing amines, you basically can draw the amine and show the hydrogens on those amine, and rest is the same like we were showing. Okay, so you should be able to recognize these compounds as well. So for instance, in this case, this is a primary amine. Why? Because we see it's bonded to 1 carbon. Here it's bonded to 2 carbons, so secondary. Here it's bonded to 3 carbons, so tertiary. Okay. And I think naming, you are okay with naming as well. This would be 1, 2, 3 carbons. Don't regard this as a corner now. Okay, that sometimes that confuses people. So when you're looking at this, this is showing you that at this corner we have NH2. So this is not a carbon. The carbon is only here. 1, 2, 3. So this is propyl. So if you, common name would be propylamine, and IUPAC name would be propanamine. Okay, this would be, again, what would be the name for this? I see there is 1, 2 carbon on this side. I see there is 1, 2, 3 carbon on the other side. So this is my long chain. I have 3 carbons, so this is propanamine, and my derivatives would be ethyl, so it would be N-ethyl propanamine. Okay, if you were doing this, in this case we have 1 2 carbon chain on this side, 1 2 carbon chain on this side, and 1 carbon on the other side. So which is my longest chain? You could regard this as your long chain. Either of these would be okay. So let's say I take this as my long chain. So these are my substituents. How would we name this? Eth means it is ethyl, ethanamine. Oh, that is if you are doing common name. I'm talking about IUPAC name. If you are doing IUPAC name, it would be ethane. Perfect. Ethanamine. And in ethanamine, where are the substituents? It's N-ethyl, N-methyl ethanamine. Right? Oh, and in this case, I forgot to mention you would also have 1 propanamine. Right? So, do you want me to write the names here? So this would be propanamine. Where is this amine located? On 1. And what are my substituents? It is N-ethyl-1 propanamine. This would be ethanamine. Perfect. We don't have to tell exactly where the amine is. Substituent would be ethyl and methyl. Ethyl comes first, so it would be N-ethyl-methyl ethanamine. Okay, and this is simple. This is 1 propanamine. It has no substituents. Okay. Okay, now we talk about some properties of these amine derivatives and amine compounds. So, what would you say? Is amine a soluble or an insoluble compound? How do we decide that? Polarity. Or amine's polar? It like dissolves like, yeah. So it is, right? Amine. And if there are amines, usually amine is a polar molecule, right? Nitrogen has a higher electronegativity. On the one is that the other thing that you would see in case of amine, we saw that whenever there could be 1 carbon, 2 carbon, 3 carbon, doesn't matter. As long as this nitrogen has 3 bonds, it has 1 lone pair as well. So if it has 1 lone pair, that means this lone pair is available to form hydrogen bond with water, right? Another thing that in case of amine, if there are any hydrogens left on amine, okay, let's say this is an R group, but there are 2 hydrogens left on the amine. In that case, what is a hydrogen bond? Whenever hydrogen is bonded to nitrogen, oxygen, or fluorine, those hydrogens can form hydrogen bond, right? So if there is any amine, primary or secondary, they usually have any hydrogens on them, right? So if they have hydrogen, this hydrogen has a partial positive charge, nitrogen has a partial negative charge, so these hydrogens are also available to form hydrogen bonds. Okay,
So if it doesn't have a hydrogen bond,
then it would not be possible for it to be soluble in water because it's not polar. It is not available to make hydrogen bonds with water. So it makes it difficult for it to be soluble in water.
but it says tertiary amines can form
With water molecules. So what happens in case of primary amine? Let's do one amine at a time. Primary amine would look like this, right? It would have 1 hydrogen, 2 hydrogen. This is primary. It has only 1 carbon bonded to it. So in this case, this is negative charge, this is positive, this is positive charge. So this hydrogen can form a bond, hydrogen bond with water, right? Let's write it in this form. So oxygen and H2, right? This hydrogen can form bond with another water, so oxygen and H2, right? So, and similarly this nitrogen can form bond with water as well with hydrogens of H2O, right? Now let's talk about secondary amine. If we have secondary amine, what happens in secondary? There are two alkyl groups, so there's only one hydrogen left. So this is partial positive, this is partial negative. So this can form hydrogen bond with water. This hydrogen can form bond with oxygen of water, right? Now when we talk about tertiary amine, what happens there? There is R, nitrogen, R and R. So it doesn't have any more hydrogens left, right? So since there are no hydrogens, they cannot form any hydrogen bond. But only way this nitrogen can form a hydrogen bond is because it still has the lone pair. So the amine is available to form a hydrogen bond with the hydrogens of water. So that's what it means here, that primary and secondary amines with fewer than 6 carbons are soluble in water. They can form hydrogen bond with water molecules. Okay, so first thing is that this and this, they both can form hydrogen bonds with water. Okay, and what is their solubility? Again, fewer than 6 carbon. If the carbon number increases, their polarity decreases, right? The polar effect of the amine group decreases.
For tertiary amines, does it mean the solubility is less?
Solubility is less to begin with. Tertiary amines can form hydrogen bond only with water molecules. Tertiary amines cannot interact with themselves. Here you can see the primary amines can also interact with themselves, right? So for instance, if there is no water, you could have one primary amine, one NH2, and other, let's keep it like this, other NH2. This nitrogen can form hydrogen bond with hydrogen. This nitrogen can form hydrogen bond with these hydrogens, right? So this can form hydrogen bond with itself. Similarly, this can form hydrogen bond, secondary can form hydrogen bond with itself and water. Whereas tertiary amines, they cannot form hydrogen bond with themselves. They can only form hydrogen bonds with water. So first thing is, this is solubility of water, right? So how they interact with water. Now, if they are making hydrogen bond with themselves or not, how will this affect their properties? This affects their boiling points, right? Because if they can form hydrogen bond with themselves, they would have a higher boiling point. Perfect. This also has one hydrogen left, right? So you could have another NH, another amine molecule that can come right next to it and form hydrogen bond with this, right? So this also has hydrogen bond. So this would also have a higher boiling point, but this would be a bit less than the primary. Whereas this has no hydrogen bonding within itself, no hydrogen bonds, not possible. It can form hydrogen bond with water because water has these hydrogen which is bonded to oxygen, but otherwise it cannot interact with each other. So therefore the boiling point for this would be very low. So this is relevant when it comes to boiling points. Okay. Perfect. So this is explaining the same thing what I just told you. Primary amines can form more hydrogen bonds than secondary amine. Tertiary amines have no hydrogen or nitrogen atom and can form only hydrogen bond with water, with the nitrogen atom. Like alcohols, the smaller amines, including tertiary ones, are soluble because they form hydrogen bond with water. So again, tertiary is also soluble, but only limited. Okay. So in amines with more than 6 carbon atom, the effect of hydrogen bonding is diminished. The non-polar hydrocarbon chain of amine decrease the solubility in water. So as long as the number of carbon atom is less than 6, they are okay. They might be soluble, but as it goes above, the solubility decreases.
6 total, right?
6.
Not like the longest chain is 6.
No, 6 in total would also be making it difficult. Okay. So for instance, which of the following compounds are soluble in water? It would be B, A and B. Perfect. So even this would be soluble and this would be soluble. This is a primary amine, so it can form hydrogen bond with water. This is also primary. This is secondary amine, so it can also form hydrogen bond with water, and both of those are less than 6 carbon atom. So they will be. Whereas the third one is an alkane. They are non-polar. They have no polar group in them, so they are not soluble. Now we'll talk about how amines can act as bases in water. Okay, so amines, like I said, ammonia can act as a base. Previously, ammonia is NH3. Ammonia can interact with water in a way that water donates its proton to ammonia. So ammonia accepts the proton. When ammonia accepts the proton, it becomes NH4 plus, and what's left is hydroxide ion. So this means that ammonia here acted as a base. One definition of base is that bases accept proton. Okay, so in this case, reminder, acids can be defined as they donate the proton. They are proton donors. They donate the proton or they lose the proton, right?
Specifically just protons or hydrogen, or is it just
Hydrogen is proton. When you have a positively charged hydrogen, so a positively charged hydrogen is regarded, there's another name for it, it is also called proton. Because when you talk about hydrogen, hydrogen has one proton, one electron, right? When you take away this electron, it changes into H plus. So what's left to this hydrogen? One proton.
specifically just hydrogen?
Just hydrogen. Just hydrogen. So it has to be H plus. Only then it's called proton, not hydrogen. It has to be a charged ion. It is called a proton or hydrogen ion. Okay. So acids donate proton and bases accept proton. So in this case, ammonia is interacting with water. What is water? Water is basically HOH. So this hydrogen from water was donated to ammonia. So here water donated the proton, so water is acid, and ammonia accepted that proton, so ammonia became the base. So ammonia and its derivatives can act as bases in water. Okay, what would they form? This hydrogen, so ammonia has what? Ammonia has 3 hydrogen bonds and 1 lone pair, right? Not hydrogen bonds, I meant 3 hydrogen bonded to it and then 1 lone pair. So when another proton comes in, what does it do? It bonds with this, because this proton has no electrons, right? So it cannot share electrons. So this interaction is basically, this type of bond is called a coordinate bond, where both the electrons are provided by nitrogen, one of the atoms. So both these electrons are provided by these nitrogen, okay, and therefore this nitrogen now has a positive charge, because technically nitrogen can only form 3 bonds, right? Because you can see nitrogen's octet is complete here. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So nitrogen is happy here. It does not need another atom to bond to. But in this case, what happens? You have nitrogen with hydrogen. Another hydrogen comes in, which is H plus. So this is a positively charged one. It would donate its electrons to this hydrogen. Okay, and what would it turn into? It will become plus because it got rid of its electrons and it has this extra hydrogen now.
But hydrogen now only has the plus 1, doesn't it? But what
Say that again. So is true in all the amine derivatives. So basically this now is called a quaternary amine. Amine. So we saw primary amine, secondary amine, tertiary amine. If I replace all these hydrogens with alkyl groups, then it would be called a quaternary amine. Okay, whenever amine is quaternary, it will always carry a positive charge. Okay, and what is this called? This is NH4 plus is now called as the ammonium ion. This is ammonia. The ion it produces is ammonium ion. So you might have heard of these names before: NH4Cl, ammonium chloride, right? So this ion is called the ammonium ion. Now what would happen if you have a compound like this? How would you name this? This is ammonium, right? Whenever nitrogen has this plus charge, it is regarded as the ammonium ion. And what does it have? It has a methyl group attached to it, so it would be methyl ammonium. This is the common name again, methyl ammonium. Okay, so nitrogen, as long as there is a nitrogen, it is going to accept a proton. Okay, once this nitrogen has a positive charge, it can no longer accept any more protons. So it could be any derivative of amine. It could be NH2, it could be N, it could be NH3, it could be NH. It will accept a proton. Okay, as long as there's no positive charge. So for instance, when we see this compound, if you take this amine CH3NH2 and you put it in water, there is this nitrogen which has lone pairs. So it will accept one proton and change into, it has two hydrogens, it gets one more, so it becomes NH3 and it becomes plus charge. And rest everything else stays the same.
When it receives proton, then that's when it becomes an ion.
An ion, because now it has a charge.
Okay.
What are ions? Ions basically are charged molecules, right? So if they have a charge, that is ionic in nature.
Because this is like on the top one is NH4 and the bottom one is NH3, but they're both ammonium ions.
They're both ammonium ion, because here what we did, this is a derivative of ammonium.
This is, as long as it just receives the charge.
As long as it has a positive charge. So what we did here, we replaced one of the hydrogens with a methyl group, right? So I took one of these away and I replaced it with a CH3. So it is still ammonium. Only thing now what I did is I replaced one hydrogen with another alkyl group.
How come it's NH3 but not NH4? Like, can I potentially not receive another hydrogen from
It cannot, because now it cannot. Why did it get this extra proton to begin with? This has one lone pair. That is why it got one more hydrogen. But now it has nothing. It has no electrons to share. So it cannot accept any more hydrogen. So as long as the nitrogen has a lone pair, it will accept a hydrogen. Once it gets this positive charge, it can no longer accept any more hydrogens. Okay. So you could take any amine. I could replace this hydrogen, the other two hydrogens with methyl as well. As long as this nitrogen has a lone pair, it can still accept another proton. Okay. So we can see. Question will come to this later on. So basically you could have, since I filled up that slide, I just needed an empty space. So I could have this CH3, nitrogen, CH3, CH3, right? So here I replaced all the hydrogens with a methyl group. Okay. What I did here is I replaced all the hydrogen in ammonia with methyl group, but this still has only 3 bonds. Whenever nitrogen has 3 bonds, it means it has one lone pair. So even this in water, if you put, it will still accept one more proton because it has a lone pair. Okay, so it will turn into CH3, and there will be an hydrogen now, CH3, CH3, and now because nitrogen has 4 bonds, it will have a positive charge, and what would be left is OH minus from water. So as long as this nitrogen does not have a positive charge, it can accept a proton. Once it gets a positive charge, that's it. It can no longer accept any more. It can no longer form any more. It cannot accept any more hydrogens. Okay. So basically this tells you that every amine derivative, be it primary, secondary or tertiary, it will act as a base in water. And what is the reaction of this base in water? You basically take one hydrogen from water and give it to amine. Okay. So irrespective of what alkyl groups are present, what matters is that this nitrogen has a lone pair. You give one more proton into it, convert it into a plus charge, rest everything else stays the same. Okay, I could change this CH3 to this CH3, CH2, nothing changes. Everything stays the same. Only thing that happens is you basically carry this over. Irrespective of what groups are attached, what matters here is nitrogen. Okay. Okay. Now, this is a base, right? Amines are bases. What do bases do when you mix them with acids?
It neutralizes.
It neutralizes. Perfect. So acid plus base neutralizes to form salt and water. That is true even here because amine is a base. Base will react with acid to form salt and water. Okay. Now, one example of this is that when you add lemon juice into fish, it kind of reduces the odor of the fish, right? Why? Because fishes have bunch of amines in them. Okay, that is giving them this weird odor. Bunch of amines in fish are responsible for that bad odor. So when we add lemon juice into it, lemon juice is acidic in nature. It has acid. So when you add lemon juice, it reacts with amine, neutralizes it, converts it into salt. So the smell is reduced. Okay, so this is an example of neutralization reaction of amine. So only thing you have to remember is that amine is a base. So if you add acid into it, it is going to react with it to form salt and water. Okay, so this reaction is called the neutralization reaction. In case of neutralization reaction, let's do a normal reaction, okay, where we don't have a fancy compound, we'll just use simple ammonia. Ammonia is a base. When you react it with an acid, this is the base, this is the acid, HCl. If you react with it acid, what happens? This is a neutralization reaction, right? Ammonia will react with HCl to form a salt. First thing, HCl will donate its H plus to ammonia, so it will turn into NH4 plus, and then what's left is Cl minus. So NH4 plus and Cl minus will now interact with each other. They are ionic compounds, right? They'll form a salt which is NH4Cl. They'll neutralize each other and form a salt. So this is how ammonia based bases react with acid. There is no water produced here because it is not like the other reaction where we have NaOH with HCl. Okay, so in this case basically the acid is added onto the base and it forms the salt. Okay, so every single time this is what's going to happen. So for instance, now we can take different derivatives of amine. So like here we have CH3NH2 plus HCl. What would happen? Same idea. This acid will give it hydrogen to amine group, and it will turn into NH3 plus. And there is a Cl minus that's left. So NH3 plus and Cl minus will interact with each other, and you could simply get rid of these charges at the end. Okay, because now they have neutralized each other. This is just showing you that why did they interact with each other? Because of the charges. Okay, but at the end they would neutralize each other, so you don't have to really write these charges. So now what is this salt called? This would be called, what is this called? This is methylamine. Okay, and what would be the ion called? Methyl ammonium ion, right? So now the salt would be called methammonium chloride, just like how NH4Cl is called ammonium chloride. So whatever is name of the ammonium followed by the name of the anion. That's how we write the polyatomic ion name, right? Name cation followed by name of the anion. Cation here is ammonium, anion is whatever you have. In this case the cation is this whole thing. So it would be called ammonium, but what ammonium? Methyl ammonium. Okay, if you put an ethyl here, it would be ethyl ammonium. If I take one more hydrogen and I replace it with CH3, it would be dimethyl ammonium. Okay, perfect. Let's try another one. Oh, same thing. So let's say if we have here, this is my amine. If I interact this base with the HCl, how would it react? This is the base. Remember, always amine act as a base. And this is the acid. So acid will first donate its proton to this and it will turn into NH2 plus. And this is Cl minus. So they will interact with each other to form this salt. Once you have the salt, you can get rid of these signs. That is just telling you that this salt is now neutral.
I see. So basically,
This would be my ion, cation. So in this case, if you were to name this, you remember where did this come from? If I get rid of these, this basically came from ammonium, right? So now this would be called dimethyl ammonium ion, and this would be called the chloride ion. When they combine, this is called dimethyl ammonium chloride. Okay, so every time take an example. If you're naming a salt, my best advice would be to take the example of NaCl. NaCl is Na plus and Cl minus coming together by ionic bond. So this is, how do we name it? We put name of the ion, cation, which is sodium, then name of the anion, which is chloride. So sodium chloride. Okay, and in this case, you know that whenever there is this derivative, this is called as ammonium. Right? This is a polyatomic ion that we have looked at before. So this is ammonium, and then if you have Cl, you could have Cl, you could have Br, you could have F, you could have I minus. It really doesn't matter. So this would be ammonium. This is chloride, so it would be ammonium chloride. In our case, we have a derivative of ammonium, so it is dimethyl ammonium. Therefore, it is called dimethyl ammonium chloride. Okay. So now I've also told you this before. These salts are basically called as quaternary ammonium salt. When the nitrogen is bonded to 4 carbons, it is a it is a quaternary ammonium compound. That's all.
and these salts are not super soluble.
They will be still soluble because they are still salts. They are still salts, right? So they are ions now. They are very polar now because they are ionic in nature. When things are ionic, they are polar because they have charges. If they are polar, they will interact with water. Okay. One very common compound that you see here is choline, which you'll see later on in the chapters that choline is very commonly found compound in bunch of lipids. And this is a very important component in case of cell membranes. So we'll talk about that later on. You don't have to remember their structure or something. It is just telling you that this is a quaternary amine. How do you recognize something is quaternary? Again, if the nitrogen has 4 bonds with carbon, it is quaternary. If it has 3 tertiary, 2 secondary, 1 primary. Okay, so let's try this question. Draw the condensed structure formula or line angle formula if cyclic for methyl propyl amine. So first thing you recognize is always start from the end. I see it's amine. What type of amine? Propylamine. And this is giving me common name. This is not the IUPAC name, right? IUPAC name would be propanamine. This is common name. It's propylamine. So propylamine means I have nitrogen with 3 carbons. Perfect. 1, 2, 3. So and then what do I have? I have a methyl. Methyl means I have another derivative on nitrogen. Rest we fill everything else up with hydrogen. So how many hand does this carbon want? 3 more. So it has 4 in total. This has 2 already, needs 2 more. This 2 more. Nitrogen total wants, yes, it wants 1 more. Perfect. Nitrogen has 3 bonds. So if it only has 2, it needs 1 hydrogen. This needs another 3 hydrogen. So that would be the structure for methyl propylamine.
So you still don't put a lone pair?
You don't have to show the lone pair if you're drawing the condensed formula. You don't have to. That lone pair is basically if you want to understand if this nitrogen, how will this nitrogen form the hydrogen bond. But when you write the structural formula, you usually don't include lone pairs. But it does have lone pair. So you're right about that. That as long as this nitrogen is not charged, it doesn't have 4 bonds, it will have a lone pair.
So nitrogen, does it follow the octet rule?
Octet rule, yeah. So each single bond is formed by 2 electrons, right? 1 electron, it's a covalent bond. So one electron is coming from this carbon, one electron is coming from nitrogen. So if we talk about this bond, it would be 2 bonds, 2 electrons, 2 electrons are here, 2 electrons are here. So how many total electron does nitrogen have? 1, 2, 3, 4, 5, 6, 7, 8. So it still completes its octet.
I'm just a little confused on the part where I would do NH like
Plus?
yeah, NH3 instead of NH4 for the most part. Why we keep it NH3?
If you keep it NH3, it's the same thing. NH3, right? That's what you're asking?
No, like for the hydrogen, right? Why would it be like 4 hydrogens? Another 2 hydrogens?
Oh, because ammonia can, so this is a derivative of ammonia, okay?
Oh, so it has to stay within 3.
It has to have 3 bonds, right? Or it can have 4 bonds, but when it has 4 bonds, it would have a positive charge. It would be ammonium. It would not be amine anymore. It would be ammonium if it has 4 bonds. And when it has 3 bonds, nitrogen can only have 3 bonds, okay? If you're talking about amine, to be considered amine. So it would only have 3 bonds. 3 bonds, you could make it with all hydrogens. You could replace one of these hydrogens with a carbon. You could replace second hydrogen with a carbon, or you could replace 3 with carbon. If you replace 3, it has no more hydrogens left. So in this case, what did we do? We only replaced 2 bonds with carbon. So it has only 1 more hydrogen left. This is an amine, it is not ammonium. If it was ammonium, then we would add an N plus and we would add another hydrogen to this amine. So now this would have 2 hydrogens in total. Okay, but if it is just an amine, it has no charges. It can make only 3 bonds. So out of those 3 bonds, 2 have been taken up by carbon. So 1 is left, which means that 1 is hydrogen. So that's the same idea that we use when we are filling up the octet for carbon. So carbon can maximum make 4 bonds. If the carbon only has 3 bonds, we add 1 hydrogen to it, right? So that's the same idea that we use here. This nitrogen here has, when there was no hydrogen here, this nitrogen had 2 bonds with carbon, but nitrogen makes 3 bonds because it's an amine. Amine makes 3 bonds, right? Which means this has to have 1 more hydrogen attached to it. Okay. All right. Next we draw 2-chloroaniline. So what would be 2-chloroaniline? Perfect. Aniline is this. Then we see a derivative which is 2-chloro. So this is 1, this is 2. So this would be 2-chloroaniline. Okay. Perfect. Okay. So next we'll talk about another functional group which is amides. Okay, so what are amides? Amides are basically, you could call them a derivative of amine and carboxylic acids. No. Okay, we saw that carboxylic acids are C double bond O OH, right? This was carboxylic acid. When we replace this OH with an amine group, this group is now referred to as the amide group. Okay, so you simply have carbonyl with an NH2 and that is called amide.
That's a functional group.
That is a functional group. That is a next functional group, and the last functional group that will be added in your course, that is amide. So when you replace the hydroxyl group with a nitrogen group, which could be NH2, could be NH, could be N, that would be all regarded as amine. As long as there is a CON bond, that is amide derivative, sorry. Okay, and what I mean by replacing these nitrogen, this is same thing. You could replace both the hydrogens with another alkyl group. You could replace one of the hydrogen with alkyl group. You could replace all the hydrogens with alkyl group. Okay, so what matters is this: as long as there is a C double bond O N bond, this is regarded as amide. Okay, how are they produced? You could imagine when this part comes from the carboxylic acid and this part comes from the amine. So when a carboxylic acid reacts with amine, it produces amide. Okay, so what you see right here, amides are produced by reacting a carboxylic acid with ammonia, primary or secondary amine. Okay, so for instance, we'll look at a reaction of ammonia in general. So if this is the reaction, what do we have here? I have a carboxylic acid, COOH. This is a carboxylic acid, and then this is the group attached to it, right? Carbons attached to it. Then we have one ammonia right here, NH3. So what would happen here? One of the hydrogens from ammonia and the hydroxyl group from carboxylic acid would react with each other, and this would be lost as H2O. As this is lost as water, whatever rest is left, it will join with each other. So this and this will now join with each other, and that would give you amide. So you simply get rid of this water and connect everything else. So this is CH3, CH2, C double bond O, single bond, and H2. Now this is an amide that is formed, and the bond that is formed right here between this is called as the amide bond. Okay, so the group is called amide, the bond is called the amide bond. The bond between carbonyl and nitrogen is called an amide bond. Okay, this is when it is reacting with ammonia. Now you could react it with any derivative of ammonia as well. For instance, if I reacted with methylamine, what is methylamine? Methylamine is a methyl group with nitrogen, and then nitrogen would have two more hydrogen because this nitrogen only has one bond right now with carbon. So you add two more hydrogens. So this is the same acid, this is carboxylic acid. What would happen here? Same idea. As long as nitrogen has one hydrogen, that hydrogen will react with the hydroxyl from the carboxylic acid, and it will be lost as water. So this is gone. Rest everything else will be joined together. So now you do the joining everything else. CH3, CH2, carbonyl group from here. It will be single bonded to nitrogen, and then nitrogen has hydrogen and CH3. So this is now amide bond. Okay. So you could take any reaction. For instance, I could do this reaction, and I could ask you what would be the product. So what you see here is that this is acid and this is amine. So whenever carboxylic acid will react with amine, it will form amide. How will it form amide? The carboxylic acid will lose its OH group and amine will lose the hydrogen. This will be lost as water, and rest everything else you join it together. So when you join this, this would become CH3, CH, CH3, CH2, C double bond O joined with this nitrogen right here, and the rest everything else stays the same, and the water is lost. So now this is called as, this makes them an amide, and the bond is called amide bond, and the group is called amide group. Okay, so it doesn't matter what kind of amine we have, what kind of carboxylic acid we have, as long as this amine has one hydrogen, it will react. If there is no hydrogen, no water can be produced, right? So which means if it is a tertiary amine, it will not give you the product, because in case of tertiary amine, what would happen? You would replace this hydrogen also with a methyl group, right? So if I want to redo this reaction, let's say right here, oops, if I want to do this reaction, CH3, CH2, CH2, C double bond OOH, right? And I put a tertiary amine here. This has CH3, CH3, CH3. Now there is no hydrogen present on this nitrogen, which means this amine cannot react with carboxylic acid.
Does it mean there's no reaction?
There's no reaction. As long as this amine has one hydrogen, it can react with carboxylic acid. Okay, so therefore it says here that this is produced by reaction between carboxylic acid with ammonia. Ammonia has three hydrogens. primary amine, which has 2 hydrogens, and secondary amine. It does not react in presence of tertiary amine. Okay?
In terms of naming.
Yes, let's do the naming now. So how would you name this? When you name it, the IUPAC name would be, so you would basically remember how we were naming the esters. What was ester? Ester was a C double bond OO, and you break the compound right here. So we'll do the exact same thing. We'll break the compound right here with the amine. Okay, so first thing you recognize, let's do the here. Okay, let's first do this reaction, then we'll come to naming. Okay, so what would be the product from this reaction? So this is first thing you recognize, this is a carboxylic acid. Second thing, the second reactant is an amine. So this will form carboxylic acid with amine forms amide. Perfect. So how will it form? One hydrogen from here and carboxylic acid from here will react with each other and will be lost as H2O. Rest everything else, it doesn't matter what is the group attached, you just join the carbonyl group with nitrogen. So carbonyl is right here, C double bond O. It is bonded to a benzene ring or a phenyl group. Okay, this is when it is bonded like this, it is regarded as, if it is an alkyl group, it would be called a phenyl group. Okay, don't worry about this. This is some extra information I just threw at you right now. Don't worry about this for now. Okay, so this is the carbonyl group. This OH and this hydrogen will be lost and the bond will be formed between carbon and nitrogen. So you bring the nitrogen here, nitrogen has a CH3, one of the hydrogens reacted, so one of the hydrogens is left with the nitrogen, so you simply put that one hydrogen right here. Okay, and if you want, you can make sure that carbon has all 4 bonds. So this carbon has 1, 2, 3, 4 bonds, and nitrogen has at least 3 bonds. This nitrogen has 1, 2, and third bond with hydrogen. Okay, so that means your molecule is looking good. Okay, one more thing, this reaction where we produce amides is called amidation. Okay, so this reaction is called amidation. The reaction between carboxylic acid with amine to produce amide is called amidation. Okay, perfect. Now let's look at their naming. Okay, my computer froze. Come on. Right. So how would you name the amides? In case of naming the amide, you're basically going to break your compound right here where the amide bond is. Okay, we are going to name our carboxylic acid separately, the component that is coming from carboxylic acid separately. This would be regarded as our parent chain. Okay, and then these would be regarded as the derivatives that are present on the nitrogen. So we'll name it the same way as we were naming the derivatives of nitrogen. So this would be our parent chain. So for instance, in case of this parent chain, what would be the parent chain be called? Amides are named by dropping the oic acid or the ic acid from the carboxylic name and adding the suffix amide. Okay, so if I was naming this carboxylic acid, how would you name this? Let's count the number of carbon atoms first. This is 1, 2, 3, 4. 4 acids is called butanoic acid. So instead of oic acid, we will call it butanamide because it's an amide, right? So you replace the oic acid or ic acid with amide. So oic, butanoic, I replace this oic with amide. So this is butanamide, first thing. Next thing we see is it has functional groups. Where are the functional groups? This is methyl. Sorry, not functional, substituent. This is a methyl, this is a methyl. Where is this located? This is on N. This is also on N. So it would be N comma N dash dimethyl butane amide. Okay, so first thing you should do is you should be able to recognize that there is a CON bond here. When there is that bond, you break the compound right at this bond and you name the carboxylic acid separately, which would become your parent chain. Okay, and this would be an amide now. Instead of oic acid, this would be amide. And rest everything else that is on nitrogen is named as its substituent. Okay, so let's try some couple more examples. Okay, so for instance, if we were to name this compound A, how would we name this? First thing I see is this is amide, CONH. So now we break the compound right here. Okay, so what do we have? Carbon 1, 2. So if it was acid, it would be ethanoic acid. So it would be called ethane amide. Perfect. And are there any derivatives on nitrogen? There is only hydrogen, right? We don't have any derivatives. So this would simply be called as ethanamide. We don't have to put any other derivatives here. Okay. Next, if I have this group, I recognize, okay, this is my amide bond. So where do I name it? You break the compound right here. This would be our parent chain. How many carbon? 1, 2, 3 carbon. So this is perfect, propanoic acid. So propanamide. Okay, if you can't remember this, if you can't do this in one step, you could do this in multiple steps. So 3 carbon alkane is called propane. 3 carbon, if it is with the acid, you would replace the E with oic acid. And now since it's an amide, you would replace the oic acid with amide. So you could do it in multiple steps as well. Okay, propanamide is our parent chain. And do we have a derivative of amine? Yes. We have a substituent. What is this? Ethyl. And where is it? On nitrogen. So this would be N-ethyl propane amide. Okay. We could try another example. For instance, if we have how would we name this compound?
So the longest chain would be 5, so it's pentanamide.
Perfect. We break it right here. We see it's amide, so we break it right here and we find our longest chain of parent chain. This is our parent chain. 1, 2, 3, 4, 5. So perfect. This is pentanamide. Perfect. And then we have our substituents on nitrogen.
So methyl and
This is 1 carbon, so methyl. This is 3 carbon, so this is propyl. Perfect. And now where are they located? On N. So this is N-propyl and methyl. Who comes first?
and methyl comes first.
Yes, we go by alphabetical order. M comes first, so it would be N-methyl N-propyl pentamide. Okay. I would not give you very complex names. For instance, I would not add like a substituent onto this. Otherwise, your naming would become a little more trickier. So I'll keep it like simple, like this. Okay. Okay. Now let's try to see if we can draw the condensed formula from the name. Okay. So what's given to us is pentanamide. We need the structure, so I start from the end. It's an amide. Perfect. Amide means what group? With amine, right? I could change this number of hydrogen as I need, but it has to be something like this, right? Okay, and how many carbon is it? 5 carbon. It's pent, so I draw 1, 2, 3, 4, 5. Now I have to include this carbon within this. Don't add another carboxylate and amine, because that would make it 6 carbons. So you need to make this carbon your carboxylate, and then you add amine. Are there any derivatives on N? No. So nitrogen will have total 3 bonds. So this has, you could do it like this as well. So nitrogen has to have 3 bonds in total. So right now it has 1, so which means it needs 2 more hydrogens. Rest, let's fill up the hydrogen. This needs any more hydrogens? It already has 4. This carbon has 2, so needs 2 more. This carbon needs 2 more. This carbon has 2, needs 2 more. This carbon has? It needs 3 more. Perfect. So that would be our final structure for pentanamide. Okay, let's go to the next one. We have here N-ethyl benzamide. So first thing I see is, okay, it's an amide group. Where is it? On benzene. So I need to draw a benzene with an amide would be, that would be aniline.
So it's double
Amide, right? So it is C double bonded O.
C double bonded O.
And then N. Okay, now N has, we see N has a derivative, N has ethyl, so I draw 2 carbons right here, right? Now we fill up the hydrogens. So how many hydrogen does this need? 3. How many does this need? 2. How many does nitrogen need? 1. This nitrogen has 3 bonds, has to have 3, it only has 2, so it needs 1 more hydrogen. This carbon? None. And this is a benzene ring, it's already all satisfied. Okay, remember this is amide. If you draw this N right here and then you put the ethyl group right here, it is going to be an amine. This would be aniline, this is not amide. Okay, so amide means it has to have a CONH. So that CO would be on benzene. Okay, any questions?
No.
Good? Okay. Perfect. Now we talk about some properties of amide. Here are some physical properties of amide. So amides do not have the properties of bases seen in amine, which means in this case, remember how amines act as bases? In this case, amides do not act as base, okay? Because this is no longer an amine, it's an amide. It is bonded to carbonyl, so it does not act as a base. Okay, primary amides have the highest melting point. How would you say that? Let's say primary amide have highest melting point, then secondary, and then tertiary. Why would you say that is happening? Primary amide would be like this. Amide, primary, secondary, tertiary mean, again we are looking for how many carbons is this nitrogen bonded to. So primary means this nitrogen is bonded to 1 carbon. Secondary would be 2 carbons. So this nitrogen is bonded to 1 hydrogen, 1 is another, let's say CH3. Okay, tertiary would be when I have 1 carbon right here, 2nd carbon right here, and 3rd carbon right here. Okay, now we have to think in terms of intermolecular forces, right? When we talk about boiling point, melting point, that means hydrogen bonds, intermolecular force. Okay, so in this case, what do we see? I see that there is 2 hydrogens. So this, if I expand it, this hydrogen positive, this hydrogen positive, nitrogen negative. Same is true for carbonyl. Remember, carbonyl is also a polar bond. So this nitrogen is also negative. Carbon is positive. So if we talk about hydrogen bond, when we think of this hydrogen that is present here is available for hydrogen bond with amine in itself. This can form hydrogen bond with another nitrogen of another amine. This oxygen can form hydrogen bond with one of these hydrogens of other molecule, right? So within the molecule, like we just saw before, this molecule can form bunch of hydrogen bonds, right? This nitrogen can form hydrogen bond. Whereas when it comes to secondary, we have one less hydrogen, right? So it would form one less hydrogen bond. So therefore the melting point is, or boiling point is lower. When it comes to tertiary, there is only this nitrogen can form hydrogen bond and this oxygen can form hydrogen bond. Rest, there are no hydrogens involved here that can form another hydrogen bond. So this has lesser number of intermolecular force. Less intermolecular force means lower the boiling point, right? So that explains why primary have high, secondary have lower, and tertiary have a even lowest melting point. Okay. Perfect. So this is showing you some examples. Let's try to draw their structures, right? So propanamide would look like 3 carbonamide, CO, NH. Right now, let's see fill up hydrogens. So when you're filling up hydrogens, also make sure you fill up the hydrogen for nitrogen as well. Okay. So how many hydrogens here? 3 more. 2. This is okay. This needs 1, 2, 3. So it needs 2 hydrogens in total. So that's propanamide. This is primary amine, right? Next we draw N-methyl ethanamide. So in this case it's ethyl ethanamide. So 2 carbon amide. So 1, 2. Perfect. This would be double bonded O with N, and then nitrogen has a methyl group. So we draw 1 carbon right here. Let's fill up the hydrogens. So this would have 3. This needs 1, 2, 3. This needs none. This needs 3. Perfect. And this is a secondary amide. Let's draw the third one. Methanamide. Meth. 1 carbon. So double bonded with N. Right? And now we have N has 2 methyl groups on it. So 1 methyl, another 1 methyl. So this I already added the hydrogens. Nitrogen needs any more hydrogen? No. Does this carbon need 1 more hydrogen? Yes. So it would be this. Okay. Now this is a tertiary amide. Only when you're looking for tertiary, you're looking for the number of carbon that are bonded to nitrogen. So when we think of this, we can see that this compound can, if I open this structure up, if I draw it like this, I know that here this can form, this hydrogen can form a hydrogen bond with something, this hydrogen can form hydrogen bond, this nitrogen can form hydrogen bond, this oxygen can form hydrogen bond. So one molecule here is involved with 1, 2, 3, 4 hydrogen bonds with another molecule, right? Whereas when we talk about this oxygen can form hydrogen bond, this nitrogen can form hydrogen bond, this hydrogen can form hydrogen bonds. So this is involved only 3 hydrogen bonds. So less hydrogen bond means lower melting point. Okay. How about this? There's only 1 carbon, 1 oxygen that can form hydrogen bond and 1 nitrogen. So this is even lesser number of hydrogen bonds. So here the melting point would be even lower. How would the question be asked? I can simply give you these 3 structures or these 3 molecules and ask you, can you arrange them in increasing or decreasing order of their melting points or boiling points. So simply, this would be the lowest, then lower, then high. Okay. Perfect. Now another important thing here is molar mass is very important. So most of the times the compounds that would be given to you in question would be similar molar mass. Because when molar mass changes, then you also have to consider the effect of the mass on the melting point, right? So you can't compare apples to oranges. You have to be given both apples to compare which one's like a bigger one or which one's a smaller one, right? Okay, so this is again explaining you the same thing that I just drew in voids. This is showing you the examples that primary amides can form hydrogen bonds with the 2 nitrogen amine groups of other amides. what makes them soluble? Again, they can make hydrogen bond with water, therefore they are soluble, but they have to have less than 5 carbon. When the number of carbon increases more than 5, the effect of these hydrogen bond decreases and the compound becomes insoluble. Okay. Secondary amines. Secondary amines, same thing what we just saw, it can form hydrogen bond, therefore they have a little lower melting point than primary, but they are still have a good, they can still form hydrogen bonds. And again, regarding solubility, as long as they have fewer than 5 carbons, they will be soluble. Okay. Next, tertiary amides, same thing, that they can only form 1 hydrogen bond. They have the fewest number of hydrogen bonds. That's why their melting point is the lowest of all. Okay, and since they can only form hydrogen bond with water through one of these locations, 1 or 2, maybe carbonyl, they could also have slightly soluble, but again it diminishes as the number of carbon atom increases. Okay, where do you see these amides usually? For instance, urea, right? Urea is basically the end product from our body after full digestion or metabolism of food. Urea is usually excreted from our body. That urea is an example of amide. Okay, where else you would see these amide bonds? You would see amide bonds a lot in case of proteins. When we talk about proteins in our body, all of those proteins have an amide bond in them. So we'll talk about that later on when we talk about that, when we come to that chapter. Okay. So here you can see some other examples of these amides. For instance, aspirin. Aspirin is one of the pain relieving drugs that is consumed, right? It reduces fever, it reduces the pain. So what is the component, the actual pharmaceutical component, chemical component present in here? Acetaminophen or phenacetin. Those are the active components that are present in this drug. Aspirin is basically just a commercial name for the drug. The actual chemical components are these: acetaminophen and phenacetin. So what you see right here, this is a CO and there is a nitrogen. So this is an amide. Same thing you see right here, this is NH, nitrogen and C double bond O, which means this is an amide. So these are basically also derivatives of amide. So this is where you see and use them usually in your normal life.
Pretty much similar.
How can I ask you a question though? I could simply give you this structure and I can ask you, what functional groups do you see in this particular molecule? So the functional groups that you see is, one I see is an amide. The second I see is this right here, which is ether.
So yeah, that's like another thing I want to ask.
If I ask you what are the functional groups present in this molecule of acetaminophen, of course I will give you the structure of acetaminophen. What are the functional groups you see? One I see is amide. Second I see is hydroxyl. Hydroxyl will basically make it alcohol. So this is an alcohol functional group that is present here. Okay. Now let's talk about certain reactions that these amides undergo. The first reaction is called hydrolysis of amide. Hydrolysis means that the amide is basically breaking. Lysis in presence of water. So breaking in presence of water. So amide is going to break into its components. So this is the reverse of the amidation reaction. In case of amidation, we saw carboxylic acid and amines react to give us amide. So hydrolysis would be reverse of that. Amide would break to produce carboxylic acid and amines. So it will break to give the products that it was produced from. So this is hydrolysis. Now hydrolysis can be done in two ways. It can be done in presence of acid or it can be done in presence of base. So these two, presence of acid or base, creates a huge difference in what products you would receive at the end. So acid hydrolysis is when it's done in presence of acid. Base hydrolysis is when it is done in presence of base. Acid hydrolysis will produce carboxylic acid and a salt of ammonium. So in case of acid, carboxylic acid will stay as acid and amine will be converted into ammonium salt. In case of base, the amine will stay as it is and carboxylic acid will be converted into its salt. Okay, so we'll talk about that. Let's look at each of these reactions separately. Okay, so when we talk about acid hydrolysis, let's look at one of the examples. So for instance, right here we have an amide, ethane amide. This is, how do you recognize this is amide? You see a carbonyl with NH. So whenever carbonyl CON bond is present, it's an amide. The reactants we see are water and HCl in presence of heat, which means this is a reaction for hydrolysis of amide in presence of acid. How would you break this? Let's do this in steps first and then you'll see what is the final product. So if we do this in steps, the reaction, the hydrolysis will break the amide bond right in the middle. What would happen here? This is supposed to form the carboxylic acid and this is supposed to form the amine. So water is essentially HOH. I could rewrite this as HOH. One of these molecules is going to H. Who would get the H? Amine would get the H and carboxylic acid would get the OH, because we need to make it convert this into carboxylic acid. So it is COOH. So this needs an OH. So OH from water goes to this and hydrogen from water goes to ammonia. So the actual result that it would give you is CH3 C double bond O, it gets the OH, so this is the acid, and amine is NH and we get another hydrogen here, so this turns into ammonia. Now this is being done in presence of acid, which is right here. So this is our acid. What are our products? Our products are also an acid and ammonia. Ammonia here is the base, and we know whenever acids and bases are present together, they are mixed together, they form salt. If it's an amine base, we just saw that amine can react with acids to produce salt. So in this case, ammonia will react with HCl. I'll write this reaction right here separately. Ammonia reacts with HCl. We saw this reaction previously. It forms NH4Cl. So this hydrogen goes to ammonia, it forms NH4 plus, which reacts with Cl minus to form ammonium chloride. That's exactly what would happen here. So this ammonia and HCl will now react with each other to form ammonium chloride. So your actual products are ammonium chloride and the acid. Okay, you don't see this is formed, but it quickly reacts with the acid that is present in solution to produce ammonium chloride. So your actual reaction would be this. You would get the carboxylic acid and the ammonium salt as a product. Okay, so whenever you see a reaction like this, simply break the amide bond. In presence of acid, the amide would be broken to give you carboxylic acid and the salt of the amine. Okay, so in here what you're seeing, this is written as NH4 plus and Cl minus. Once you make this, convert this into salt, you really don't need to show the charges. You could simply write this as NH4Cl, ammonium chloride, and this would be 2 carbon acid, which is 1 2, so it would be ethanoic acid. Okay, so that is acid hydrolysis of amides. What happens when we are working this reaction in presence of a base? In presence of base, I can show you this reaction 2 ways. One is I can show you the mechanism of this reaction, which will make you understand what, why, and how did we exactly get into this product. Okay, but for your terms, you could simply do this reaction in 1 step as well. Okay, so let's first look at the mechanism of this reaction. Okay, if you follow the mechanism, it would be done in steps and then you would get the exact same products as you could get just by simply doing this reaction separately. Okay, if you want to do this separately, this is an amide. The first thing I see, this is amide. I see a CON bond, which means this is amide. Now amide in presence of base and heat That means this is hydrolysis in presence of base. Simply what you can do is, you have NaOH, this could be NaOH or KOH. For instance, right now it's NaOH, you would simply break this NaOH right here. One of these carbon, either the carbon and the nitrogen, one of them is going to get a hydrogen, the other one is going to get NaO. The hydrogen goes to the nitrogen right here, and NaO goes to the carbon right here. Okay, so the products that you will have is nitrogen, which has hydrogen CH3, will get one more hydrogen and it will turn into methanamine. And this carbonyl carbon right here received the ONA, so it will turn into CH3, CH2, C double bond O, ONA. So now this is the carboxylate ion salt. So these are the actual two products that are produced in this reaction. How do we name this salt? If you guys remember, we did this in carboxylic acids as well. You can also go back and rewatch that video. But if we were to name this, always pick the example of simplest salt, which is NaCl. NaCl is sodium chloride. How did we name it? We named the cation first and then the anion, right? Anion here is chloride. So name was sodium chloride. Let's follow the same rule. Let's name the cation and then the anion. The cation here is sodium. The anion here is right here. And this anion is coming from carboxylic acid. So how do we name the anion from carboxylic acid? It is called carboxylate. It ends with ate. You simply take the name of the carboxylic acid and replace the oic acid with ate. So for instance, this would be how many carbons? 1, 2, 3. 3 carbon acid is called propanoic acid. You would replace this oic acid with 8. So it would become propanoate. So the answer is sodium propanoate. That is how you would name this particular salt. And those would be your products. So you can see right here, the product is sodium propanoate and methanamine. Now this is if you're just doing the direct reaction. Now you could ask me that this is called base hydrolysis. So this is in presence of hydro, but I don't see any water involved anywhere because this is not the actual reaction that is happening. The products and reactants are these, but the reaction is following a different mechanism. So let's look at the actual mechanism. I will never ask you that mechanism, but this is just to help you understand exactly how is this happening. Okay. Regarding the products, you can simply break NaO right here, give the amine the hydrogen, and the rest would go to carbonyl carbon. Look at the mechanism of how this was done. Again, you don't have to know this. This is just to help you understand exactly what is happening. So in this case, this is an amide. This is again done in presence of water. So water is involved here. Okay, you just don't see it written out in the reaction. So let's put an HOH here. Okay, this is water. So amide will break right here. What will it produce? Just like previously, the OH will go to this carbon and H will go to the nitrogen. So the products produced would be CH3, CH2, C double bond O, OH. So this is the acid, carboxylic acid, and the amine. Amine would be CH3, nitrogen with one hydrogen and second hydrogen that we just got from water. So this is the amine, which is the amines, remember, act as base. So this is the base. Now this reaction is being done in presence of NaOH, which is a base. Now again, we have acid in this reaction as a product and base is present in excess. So this acid that is produced is going to quickly react with the base to produce salt and water. This is the neutralization reaction of carboxylic acids that you guys have seen in previous chapter. How would this reaction happen? Remember, NaOH is a base. So NaOH breaks down to give us Na plus and OH minus. So the OH from Na, the base, and hydrogen from carboxylic acid are going to react with each other to produce, so I'm doing the second reaction from here now. They are going to react with each other to produce water, and rest will join with each other. So this ion and this ion are going to join with each other now. So we'll be left with, let me put this in a different color, the carboxylate ion and the sodium ion will react with each other to form the salt. So we'll have CH3, CH2, C double bond O, O, N, A. So you see the products are same. What we saw right here is the salt of the carboxylate, and this amine which was produced is right here. So the products are same like previously, but this is how the reaction is actually happening. It is not a single step reaction. There is water involved in this reaction, but if this mechanism is kind of not required for you, this is kind of out of your syllabus, but this is actually what is happening in this reaction. Okay, so why do you not see any water written out here? So you see here, this is water which is produced in the reaction, and we also used one water molecule which is one H2O as a reactant. So when reactant and product, it's the same water molecule, so you don't show it in the reaction, they cancel each other out. One water is used, one water is produced, so it's a common reactant and product, therefore you don't see it written out in the reaction, the overall reaction, but actually it is involved in the overall reaction. So this is showing you the complete mechanism of how this hydrolysis of amide is happening in presence of base. But if you are okay with just remembering that NaOH, you can break it right here. One would get the hydrogen, the other would get the NaO. That's good enough for you guys. Okay, because for you, the question would basically look like a base would be given, an amide would be given to you, and the question would be what would be the product of hydrolysis of this amide in presence of base. Okay, we'll try a couple questions. Let's try some examples now. So now the question is, draw the condensed structure formulas and write the IUPAC name for the products from the hydrolysis of N-methylpentanamide with NaOH. Okay, so what is happening? We are doing hydrolysis of this particular compound in NaOH. In presence of NaOH means we are doing base hydrolysis. Perfect. So let's first make our reactant. What would a reactant look like? It's an amide with 5 carbons. So I draw 5. 1, 2, 3, 4, 5 carbons. Then it's an amide, so it has to have this CON bond. Then do I have a derivative of N? N-methyl, so we add a substituent on N, it's a methyl, so CH3, or you could simply just put 1 carbon for now, right? Now let's fill up all the hydrogens. So how many hydrogen does this need? 3. How many hydrogen does nitrogen need? 1 more. Total hydrogen on nitrogen, total bonds of nitrogen should be 3. It has 2, it needs 1 more. This carbon already has 1, 2, 3, 4 bonds, so it's okay. The next carbon has 2 bonds, so needs 2 more. This has 2 bonds, needs 2 more. This has 2 bonds, needs 2 more. This has 1 bond, so it needs 3 more hydrogens. Okay, so this is our structure of N-methylpentanamide. Now this will react with NaOH. If you want to do this in one step, you could think that the compound NaOH will break right here, hydrogen will go to amine, and NaO will go to carboxylate, and this bond will break right here. Okay, so what will be our products? Our products would consist of CH3. Everything stays the same, only thing that you will add compounds to the carboxyl group. So we have 1, 2, 3, 4 carbons, and 5th is the carboxylate with ONA.
It's ONA?
Yeah, because it has the O, right? NaO. So this, we are only separating this O and hydrogen.
I meant like the order of it.
Oh, the order, yeah. So Na is bonded to the O. So it would be like this, because if you put it in this form, NaO, then you're basically telling me that carbon is bonded to Na, which is not true. What is happening here? Carbon is bonded to oxygen, and this oxygen has a negative charge, nitrogen and Na has a positive charge, right? So that is the interaction. So O should be in between. Plus the amine, which is CH3NH2. So let's name them now. What would be name for this? First thing, this is sodium. And now we name the acid. So how many carbons is it? 5. So pentanoic acid would become pentanoate. So it would be sodium pentanoate. And how about this? Methanamine. Methanamine or methanamine. Alright? That would be base hydrolysis of amine. Okay, so the products are also shown to you in slides. Let's try this question. Draw the condensed structural formulas for the products from hydrolysis of the following amide with HCl. So in this case, we are doing acid hydrolysis. So what do we know about acid hydrolysis? This HOH, this is water, break it into HOH. Where is the amide going to break from? Right here, perfect. Who gets the hydrogen? Amine. And who gets the OH? Carboxylic. Perfect. And now we know this amine group is in presence of acid. So this amine which is formed is going to form a salt with acid. Perfect. So what will be our compounds? Let's make the acid first. The acid would look like CH3, CH2, C double bond O, OH. The OH went to carboxylate, right? Now we add the amine one, which would be CH3, N gets one hydrogen, and then it also gets the HCl, so it will become NH2Cl. So what would be the name for this? Perfect. This is 3 carbon acid, so this would be propanoic acid. And how about this? This is a salt. So how do we name the salt? Again, NaCl. Na is sodium chloride. So you first name the positive charge one. Oh, one more. The positive charge one would be the ammonium ion, right? So we name this first and then this. This is chloride, so you can simply write chloride for this. Now we name this. This is perfect. This is methyl ammonium. So methyl ammonium chloride. Okay, so that is acid hydrolysis. Perfect.